Hi everyone, welcome to a Konveyor meetup. So today we have Saurabh and Rachel from IBM Research who will be presenting tackle tests to us. We're super excited mostly because this is a tool that was recently contributed to the Konveyor community. And just to give you a little bit of context, so this slide right here shows how the different tools within the community fit to the different 6 Rs within your modernization migration path to Kubernetes. Tackle test does fall under tackle. So you'll see that tackle is in two places, one right here at the beginning of that modernization migration path. And that's because it helps you with the application inventory, and also it helps you understand what you should be containerizing and when. And then it also helps you with actual refactoring of these tools. So tackle test fits, you can think of it as within the tackle tool. So just want to give you that context before we go on. And just some housekeeping items. So I will send out the recording to this probably 1 or 2 days from right now. And aside from that, if you have any questions, please put it in the Q&A. I probably won't ask the presenters about it until once they're done with the presentation. But as they come to your mind, just go ahead and put them in there, and that way they have a good amount of items to go over afterwards. All right, so Rob, I'll hand it over to you first.
Great, thank you, Jonathan. So let me share my screen. Okay, do you see it?
Yes.
Okay, perfect. All right, so thank you for the introduction, Jonathan. So today we're going to present this testing tool called Tackle Test. It's basically a fully automated unit test generation tool for Java. And this tool also generates test cases with assertions, which means that the test cases can be suitable for performing differential testing between two versions of a Java application, right? So you can use this tool as a general purpose test generation tool in any scenario, but in the application modernization scenario, there are very compelling use cases for this. So in most application modernization projects, the changes made to an application are functionality preserving, which means that the functional behaviors of the legacy application should be preserved in the modernized application. So in this scenario, you can use a tool like Tackle Test to generate test cases on the legacy app, and then add assertions to those test cases by observing the runtime states that are created during test execution, and then run these test cases with assertions on the modified app. And then if the test case fails, then you have to investigate the root causes of why the test fails. So if an assertion fails, it could be for several reasons. First of all, your assumption that the modernization activity is functionality preserving could be incorrect, in which case you have to revisit that assumption. It could be the case that you've introduced a bug in the application. So then you have to do root cause analysis of what the changes were and why the test is failing. A third reason is that the assertions could in fact be not reliable, or it could be a flaky assertion. Now, this is a problem that we try to address in this tool. So when we generate the assertions, we actually run the test sequences multiple times, and only if we observe the same runtime states in multiple executions, then we create an assertion on that. So this is basically how the tool can be used in the application modernization, and we believe that it can be a big value add, right? A lot of the effort in modernization projects is spent on validating that the modernized application actually preserves all the functional behaviors of the legacy app, that nothing is broken. And this is especially challenging in the context of legacy apps, because many times these apps don't have automated test cases, or if they have automated test cases, they may have obsolete test cases, or they may not have enough coverage. So a lot of the tasks have to be done by hand manually, which is tedious, time consuming, and plus you may even miss detecting broken behaviors. So the Tackle Test Generator component at a high level consists of two components. There is the core test generation engine, which is implemented in Java. And then there is a Python-based command line interface, which is the primary interface through which users would interact with the tool. And then both of these components interact with two open source tools. These these test generation tools came out of academic research. So there's one tool called Randu that performs basically feedback-driven random approach to test generation, and EverSuite that implements evolutionary algorithms and constraint-based algorithms for generating test cases. And both of these tools are kind of driven by code coverage, right? So they try to target statements and branches in the code and try to maximize coverage. Now, the test generation engine of TackleTest actually implements a new coverage criterion, a new way of computing coverage goals for testing. And in this approach, what we do is we apply combinatorial test design to method interfaces and method signatures. So we analyze all the methods in the application under test, all the public methods. We automatically create a CTT model for every method. And the model basically says for each formal parameter of the method, what are the possible types that you can create? What are the possible types that you can invoke the method with? And then from this model, we automatically generate a test plan, which basically consists of a set of rows, and each row in this test plan becomes a coverage goal for which the test generation engine then tries to create a covering sequence. And we have some early evidence that this way of testing actually generates test suites with some good properties, like these test cases are much more compact in size than what you would get from Randu and EverSuite. And then they still attain good coverage in terms of statements and branches. So it's actually a good trade-off in terms of generating an efficient test suite consisting of diverse test cases. So using the CLI, basically the user can either perform CTD guided test generation, or if you decide to use Randu and EverSuite standalone, then the CLI lets you do that as well. So this slide shows basically what the usage flow is and what artifacts are generated at various steps. So the user would start by creating a configuration for the application under test. So the configuration describes the application in terms of, you know, where are the classes of the application, what are the library dependencies, and so on. And so this configuration is captured in a TOML file. Then once you have created the configuration, you go ahead and generate the test cases. And then after this, obviously, you'll have a set of JUnit test cases. We also generate Maven and build files. So if you choose to execute the test cases using and Maven, then you can use these files. And then in addition, we also generate some reports. So there is and these are basically in JSON and HTML. So these reports would show you what coverage of the test plan was achieved by the test suite, and then, you know, some summary information about the test generation process. Once you have the test cases, then you can execute the test cases. The CLI supports test execution, but you don't necessarily have to use the CLI for that. Since these are regular JUnit test cases, you can use any JUnit runner to run these test cases. You can load them in an IDE, run it that way, or you can run it any other way. But if you use the CLI, then after the execution of the test cases, we generate a set of JUnit reports and Jacoco coverage reports that basically show at the class and method level what are the statements, branches, and so on covered in code. So we'll now go over each of the three steps. So the first step, like we showed in the previous slide, was creating the configuration for the application under test. So basically, the configuration file is a set of name value pairs that is organized into different sections, right? So there's a section where you specify the application name, the application classes, what are the library dependencies, and then the name of the test directory. And some of these options are required, whereas others you can omit. So for example, you don't need to specify the test directory, and by default, it will create a directory with the name of the application and some suffix, and that's where the test cases are placed. And then you also have some configuration options to basically configure the behavior of the tool for the generation part and then for the execution part, right? So for the generation part, for example, you can say what's the time limit per class, so that, you know, you can control the total test generation time in that way, right? And similarly for execution, you can specify a few options like what build type to use, whether Ant or Maven, whether to generate coverage information, and what type of instrumentation to perform. So all these configuration options are provided in this TOML file, and some of these options can actually be overridden from the command line. So once you have the configuration file created, then you can generate the test cases. So here the main thing you have to do is select the test generation strategy. Right? So like I said earlier that, there's the CTD guided test generation, which is supported by the option called CTD amplified, or you can use EvoSuite and Random standalone, right? And if you select CTD amplified, then you also have to specify what is the base test generator. And we'll explain in a later slide what we mean by that. But as the base test generator, again, you can select EvoSuite and or Random. And so this test generation can basically be launched from the command line. So here on the right side, you see a screenshot of how you would invoke it. So you specify the config file, you run it in the verbose mode, and then you say generate CTD amplified, and then you provide some options for the CTD amplified. Right? So here we are saying that use the combined base test generator and don't add diff assertions. Now, one thing to keep in mind is that if you have a large application with hundreds of classes, then test generation is going to run for several hours, right? And we have some early data here where we applied this tool to an enterprise Java application that had 387 classes and over 1,400 methods. And in this case, when we did CTD modeling, our test plan size was 12,000 or 297. So which means in theory, we would generate more than 12,000 test cases for this application, right? And after about 1 hour, where we used a time limit of 2 seconds, the tool generated about 5,400 test cases, which covered 180 classes. And so 2 seconds, again, may not be sufficient time. So, for getting higher coverage, you would want to use higher time limits. But this sort of gives you an idea that for large application, you have to let the tool run for a few hours, right? But there are options for controlling the test generation time. So you can, of course, play around with the time limit. And you can also focus the testing on specific classes of interest, right? So you don't have to generate the test cases for the entire application. If there are some classes that you're interested in because the code is complicated or you've made changes, then you can just tell the generator to generate test cases for those classes. So reducing the scope of testing in that way will also control the test execution time. And then finally, there are a few other options that you can also use to control the test generation time. Okay, so at this point, I'm going to basically demo these two steps, the configuration and the generating test steps. And then I'll hand over to Rachel to take you through the rest of the presentation and the demo. All right, so once you have downloaded a tool and set it up, then basically this command tackle test is available to you. And so you can type help and it will basically show you what are the options that are available to you. So this says that at the top level, I have these 3 commands: config, generate, and execute. And if you look at the options for config, and says again, you can perform the init or the list command. So what I'm going to do first is I'm going to create an empty config file. So I'll say test config init, and I'll give it a name of a file. So what this is going to do is basically create an empty file. And so let me open up that file. So here you see that there are all these options that it created, right? And a lot of the configuration options basically have default values. So for example, by default, test generation will spend 10 seconds on every class, right? So now I'll go ahead and add the minimum number of options that are needed. So I'll give this application a name. And by the way, the example application that we're using, it's an open source Java application that has about 25 classes and 74 methods. And this is an application that performs some computation of chemical codes. It's an open source application. So I'm gonna give this application a name. Now I have to specify the class path file. So basically I need to tell the tool what are the library dependencies of these applications, right? And the reason this is needed is that as we generate test cases, we execute those test cases, right? And at runtime, you need the library dependencies available. So if any library dependencies are missing, then basically during execution, you'll get failures. And if that happens, then the tool throws away the test cases that it generates. And so in order to do that, we have a we have a class path file that we have created. So basically, you can specify it in a file where every line is an absolute or relative path to the dependencies. So in this case, this application has these 3 dependencies. So what I'm going to do is basically take this path and then provide it here. Now I have specified that this is the file where all the library dependencies are there. Then I need to specify what are the paths to where the application classes are, right? So here again, I'm gonna, in this case, I'll go up to the classes directory. And so that says that all the application classes are under this directory. And this is a list, so you can provide multiple items. And by the way, this tool works on binaries, right? So you have to build your classes and then it works on class file. It doesn't work on source files. And then a few other options I'll update here is that I'll change the time limit to 2 because I want it to run in a short amount of time. And then another option I'm going to control is changes this number of sequence executions. I'm going to change it to 1 from the default value of 10. And what this is changing is that after the tool has generated a test sequence, it actually executes it multiple times to make sure that there aren't any flaky behavior. So which means that the tool passes sometimes and fails on the other times, right? And these multiple executions are also used for creating reliable assertions. So only when we observe for certain program variables the same state in every execution, then we're going to create an assertion on them. If you see different values, then we're not going to create an assertion. So that's why we kind of try to avoid if there is some randomness in the behavior of the application. And then here the base test generator says combined. I'm going to change this to EvoSuite. I'll say let's just use EvoSuite as the base test generator. And then I save this option, save this file. So these are kind of the minimal set of configuration that you have to do. A lot of the other options, I'm basically going to just leave it to the default values. And then at this point, I can start launch the test generator. So I specify what the config file is. I'm going to run this in a verbose mode, and we actually suggest that this is the mode that you should use always, because then you'll get progress messages on the tool. And then we say generate, and I want the CTD amplified strategy for test generation. At this point, it's going to do the CTD modeling. It generates a total of 77 test combinations in the test plan for 74 target methods. And then it has launched the base test generation, in which case it is EvoSuite. And then the started message is actually being printed on this file, right? So we can actually look at the contents of that file. So now what's happening is in the background, EvoSuite is running, and you can see it's going through all the application classes and generating test sequence, right? So this is basically it's using evolutionary algorithms or genetic algorithms where it comes up with random inputs and then evolves them through successful generations to create test cases. So this is going to take a couple of minutes basically to get through all the classes, and at the end of it, what you would have is a set of base test cases. And once those are created, then the test generator would move on to the next step, where it will start creating test cases for covering every plan every row in the test plan. So in this case, the test generator will try to create 77 test methods, since that's the number of rows we have in the test plan. Okay, so while this is running, we'll actually switch over. I'll hand over to Rachel. She'll take you through the rest of the slides, and then we'll pick up back on the demo again.
And Saurabh, before we hand it over to Rachel, I did get a question that's probably a good time to ask.
Sure.
The question is, could you explain the test generation time limit again?
Right, so that's time limit specified in seconds, about the amount of time to spend on each class of the application. So when I said 2 seconds, the tool is going to spend, well, in theory, no more than 2 seconds per class, but then, if it's in the middle of a computation, then it doesn't just kill it. So sometimes it can be a little bit more. But yeah, so roughly the total test generation time would be, the time limit value that you specify times the number of classes plus some delta.
Okay, thank you.
Okay, so now I'll share my screen. And can you see my slides?
Yes, you're good to go, Rachel.
Okay, great. So I'll explain, I'll illustrate with an example how our CTD amplified test generation strategy is working. So we have here an example of a simple method called draw shape, which receives 3 parameters, and their types are specified here. So how do we generate a test plan for this method with combinatorial test design? I remind you that the goal is to invoke this method with many variations of the types of the parameters, so we get to execute many different behaviors of this method. So the first thing we do is we do very straightforward type analysis to understand what are all the possible types of each parameter here. So for example, shape is an abstract type, so we via class hierarchy analysis, we understand that the actual concrete types that it can receive are triangle, square, and circle. And similarly for the other 2 types, we understand what are all possible concrete types that can be actually instantiated here in this application. And once we have we are done with this type analysis, we create a CTD model which simply for each parameter type, for each parameter, it lists all the types that this parameter can receive. With collections, there are more complications. The modeling is a bit more complex. I'll not go into that, but for the simple example where we don't have collections like lists and maps, so it's really straightforward. And now we apply a combinatorial algorithm to generate the test plan. So what does it do? The combinatorial algorithm receives the model, the parameters and their values, and interaction level, which is the coverage requirement for the algorithm. So if we give it interaction level 1, like in the example here, then the algorithm will generate a test plan where each row where for each value of each parameter of the model, we have at least 1 row in the test plan that covers it. So each row here represents some kind of configuration with which we invoke draw shape, for example, with circle, spreadsheet, and data specified in the first line, in the first row. But we are guaranteed to have every value covered here. If we want to raise the interaction level to cover more, then we can specify interaction level 2. And now we are guaranteed that each pair of types, like circle and spreadsheet or square and timestamp and so on, are covered by at least 1 row here. We still get a huge reduction in the number of test cases. Here's a toy example, so you don't see the huge reduction, but the total number of possible combinations is 12, and we need only 6 of them to generate a pairwise test plan, a test plan with coverage of all pairs of values for all pairs of parameters. So this is the testing strategy that guides us. Now, what do we do with these rows? So the flow is as follows. So as Saurabh mentioned earlier, the input from the user can be either a set of classes which should be targeted if the user knows of specific classes that are affected and need to be tested, or if the user doesn't specify target classes, then we target all the classes of the application. Then we generate for all the public methods in all the target classes, we generate a CTD test plan as I just illustrated. After that, we use base test generators, which can be either Rundup or EvoSuite or both, to generate test sequences that target every method and every type that was specified in the test plan. These are our basic block test sequences, and then the third and final step, which we call the extender, is to take these initial sequences, go over the test plan of every method, and for every row, try to create a sequence in which eventually the method is invoked with exactly the types that were specified in the test plan. using the initial sequences that Rundup and EvoSuite created, or Rundup or EvoSuite created. And while we are creating these final test sequences, we are also executing them in memory, both to make sure that they pass. If they fail, then we are not going to use them. And if they pass, we can also record the behavior. We record all the values of the objects that are created during this sequence execution to add them automatically as assertions to the final test. And eventually, we write these final sequences that the extender created as JUnit test cases. So the final output of our tool is JUnit test cases can be with or without assertions, depending, the default is with the diff assertions, but the user can specify without. We also create Maven and Ant build scripts if the user wants to use them for executing the test cases. But they, as Saurabh mentioned, the test cases can be executed by any JUnit runner. And we also generate reports for the test plan coverage and the test generation achieved coverage. So these are our the artifacts that we generate eventually. And now we'll go back to showing what happened in the generation. And so it was the same example that Saurabh showed before. Once the generation is completed, we get a message where JUnit test cases were saved, as well as the CTD coverage report and the Ant and Maven build scripts. So let's take a look at how the test cases that were generated. They were generated here. Here's the name of the application and CTD amplified tests. So we got 24 test files generated for 24 classes. And in each test file, we have a test method. So let's take a look at one of them. So here we have, for this structured class, we have 7 test methods. We can see that every test method ends with a call to one of the public methods of the class under test. And after every statement, we have an assertions, either assert equals or assert null, if that's the case, where we force the value of some field of the created object to be the same as the value that we recorded during test generation. So this is how the test cases look like. And now we can also see the CTD report, the coverage report. So after we generated the test cases, even before we started executing them, we already know how much, what percentage of the test stands we were able to cover, what percentage of the rows we were able to generate test sequences for, and this is what the CTD summary shows us. So overall, we covered 80% of the rows in the test plan, and we can drill down to the class and method level to see exactly which type combinations and which methods were covered and in what with what percentage. So this is the CTD coverage report. So now I'll go back to the presentation. So for test execution, again, we can use any JUnit test runner, but we can also use our execute command that currently supports Ant and Maven, and Brill will be added in the future. And there are 2 types of generated reports. The JUnit report is simply provide information about the execution and of the test and the result, and the code coverage report at different levels of granularity, instruction, branch, method, and so on. So now let's execute the test cases using the command we can use the command pkl test, again with the verbose option, and we specify the same config file that we specified before, and now type execute. So now we are starting to first we compile all the test files, and then we run the Ant script and run the test cases with JUnit and Jacoco enabled. So we have two reports. We have the JUnit reports and the Jacoco reports. Let's take a look at them. So now we have here in this folder, also in the TKL test reports folder, we also have JUnit reports. And we can see that we had 61 test methods and all of them passed. We can also see execution times and so on. And we can also look at the Jacoco report to see what was the code coverage that was achieved. So overall, we achieved 75% instruction coverage. And we can drill down, and you can see also 41% branch coverage. We can drill down to the class and method level to see, again, at these levels, what percentage of coverage we achieved and where are our coverage gaps. Okay, so going back to presentation. So this is simply the generate execute. How do we start working with the tool? So we simply we first need to clone the tackle test generator CLI and follow the README instruction there. There is an installation phase, initial installation phase that can be done either with Docker or with the local installation. And then we advise to apply the generate and execute commands to a toy example that is included in the repo. It's called IRS. It's located under test data. And this is to make sure that the installation worked well and to see that the commands are working and the instructions appear in the README. And then there's also a quick start guide in the README where you first create an empty config init, an empty configuration file with the config init command as Saurabh demonstrated, and then run these two commands as we demoed. And finally, we want to briefly describe upcoming features, ones that we are planning and ones that we already started working on. So first of all, we want to improve both the code coverage and the CTD test plan coverage that we are achieving. We have different ways of doing that. We know already of places where we can improve, like in the parsing of the sequences that EvoSwitch and Rundup generated. We can utilize more of what they generated. Moreover, we want to reach some kind of optimal strategy where we take the CTD guided approach and still utilize also EvoSwitch and Rundup code coverage guided approach to reach an optimal test plan in terms of both code coverage, CTD coverage, and because the ultimate goal is to reach optimal fault detection. We also want to somehow combine these in an optimal way. We believe that by using CTD to target methods with complex interfaces, while using Rundup and EvoSwitch to target methods with complex implementation, we can get the best out of both of them. And it's also important to keep the number of test cases low, or especially if they are later on picked up and used as part of a CI pipeline. So we cannot afford to have hundreds and thousands of test cases. We want to keep the number low, but not compromise on the coverage. And and there are also some other features that we need to that we want to address in the algorithmic improvements. There are also usability improvements that we want to do, as we mentioned before, support the Gradle build and also integrate with Konveyor tools. And finally, this tooling works only at the unit level, but there's definitely a need also for automatic test generations at other levels of testing, such as UI, UX, end-to-end testing. and API level testing. So we already started work on end-to-end UI automatic test case generation, which is based on a crawler that infers a model. So this is a model-based testing approach where the test cases are derived from the model. And we plan to leverage NLP for labeling these the generated test cases with the semantics, because the main challenge is to create test cases at the UI level that have that represent meaningful business use cases of the application. And then we also want to use these UI level test cases that we generate and carve from them lower level test cases at the API and also unit level. And these test cases will be more realistic because they are carved from realistic UI level tests. So they actually represent actual states and sequences that can occur in the application and not via random assignment. So with that, I'll stop and call for the community to get involved and try out the tool, provide feedback, and contribute to the tooling. Thank you.
Thank you, Rachel and Saurabh. So we have a couple questions that have been building up. So the first one is, and this question came in whenever Saurabh had just finished his demo, but the question is the execute will be against the same files?
Will the execute?
Yeah, go ahead, Rachel.
Can you clarify the question? The execute will be against the same files that were generated, yes. That will be, okay. The execute will operate on the test files that the CTD Amplify generated.
Right.
Yeah, I'm pretty sure.
And to execute it against the modified version of the application, right, all you have to do is update the path where the application classes are, right? So if you remember in the configuration file, I was specifying this is where my application classes sit. And so you can change that against, and whatever you specify there, test cases would be run against those.
Okay. And then the next question is, from the modernization and migration perspective, will we be running the tests at both the source, the original application, and target, the migrated application, and then you compare the results?
The test cases are generated on the legacy, on the source application, and the assertions are generated based on the behavior on the legacy application. Then you can take those test cases and run them also on the modernized version, verify that the application still behaves as it behaved on the legacy, so nothing in the functionality is broken. So take the test cases. You may need to adapt them or maybe change them a bit to work on the modernized version, but the idea is to generate on legacy and then run also on modernized.
Yeah, and so after generating the test cases, you would want to run them on the legacy ones just to make sure everything passes. Although, you know, we do try to guarantee that all the generated test cases will pass. Anything that fails, we throw it away. And then once you run them on the modernized version, then yeah, anything that fails basically is something that you'd have to look at, right? So you don't have to actually do a side-by-side comparison because the behavioral part is encoded in the test case in the assertions, right? So when an assertion fails, then that's where you have to see, okay, why did it fail after modernization, right? Is this an expected failure, or is this something that, you know, is a bug in the changes that you made to the application?
And by the way, the test cases can fail also not only in assertion failures, they can actually throw exceptions and fail in other ways because of bugs that were introduced that are caught in other ways than the assertion.
Okay, that makes sense. Thank you for the context there. All right, the next question is, does the tool cover method level unit test? Is that what it covers?
Yes, yeah. So we target every public method of the classes that you specify, and we generate, the CTD model is generated at the method level, right? So we generate one model and one test plan for a method, and then we generate a set of test cases for every method. And these test methods are then grouped into test classes the way you usually do with JUnit, right? So what you get are class level files where we have test cases for every public method of that class.
Okay. And On this question, I don't know if this is enough context for the both of you. At what point is the instrumentation added and the reason behind it?
Instrumentation is done, so there are two places where instrumentation is done, but mostly instrumentation is done. What you saw in the demo is instrumentation by Jacoco. It instruments in the execute command. Jacoco is activated as either as a Java agent, or you can do also offline instrumentation just to measure code coverage. So it's part of the build file that's where it's happening, and the reason is to measure the code coverage. So that's where instrumentation is taking place. In addition to that, EvoSuite, one of the test generator, also does instrumentation to handle different challenges in test generation. So it has also has its own class loader and performs instrumentation during its test generation, but that's more transparent to the user.
And if you want to not do code instrumentation, then with the execute command, you have the option of not generating coverage reports. So in which case, we're not going to use Jacoco either in the online or the offline mode. So yes.
Right.
Okay. And then the next question is, how much a business needs is met by this random test? How much better is it than the handwritten unit cases?
So,
right.
So that's first. You can go first, Saurabh.
Well, yeah. So you're right that these are test cases generated with mostly random inputs, right? And so they won't be as good as a human written test case where you're taking into account your knowledge of the domain, your knowledge of what are the business use cases of the application. So these tests are not taking those into account, right? So here the value is that it's a fully automated process. It attains good code coverage, and then if there are obvious failures, then or the ones that the assertions can detect, then it will detect those, right? So but in terms of exercising business functionalities, these test cases won't come close to what a human would write. Right? And this is the part of the problem that we want to address with the future work, like in terms of the web UI testing, where we actually want to generate meaningful flows through the application, right, that an end user would exercise. And once we have those test cases, we can actually carve out lower level test cases out of those. And those test cases, we believe, would be much more realistic than what we are seeing by directly targeting unit level generation. And so, yeah, absolutely. I mean, these test cases, we won't put them close to what a developer would write, right? The value here is full automation versus manual effort.
Yeah, so I have two things to add to that. So one is that if you saw so first of all, yes, definitely the test cases that we will carve from UI will be, on the one hand, automatically generated, but on the other hand, more realistic. If you saw the numbers that Saurabh mentioned before for the enterprise application, there were thousands, or many thousands even of test methods. So the human effort that is saved here is really huge by doing the generation automatically. Of course, and as long as the code coverage is high, we expect that they still will give some value, but of course not as developer might reach. But that's still a huge gain, and in some cases there is no ability to sit and write all these thousands of unit level test cases. And one more thing is that we can also incorporate, if you already have unit test cases, one extension will be to also incorporate those into the process, generate test cases only for the parts that the handwritten test cases are not covering, and others if assertions both to the automatically generated test cases and to the handwritten test cases to enhance those as well.
Okay. And the next question I have for you is this applicable for all types of refactoring by Konveyor? I think that's what they're trying to say.
Right.
Yeah, so I'll let you guys take it from there.
Yeah, so that depends on the kind of modifications you're making, right? And so this is because this is testing at the unit level, right? If you're if the changes that you're making is in some sense changing something in terms of the call graph of the application or the behavior of the methods, then you wanna use this method, right? But if your modification does not involve, you're simply migrating from replatforming the application and nothing changing internally at all, then this level may not be as useful, right? And here again, I think the higher levels of testing at the API and the UI level would be more useful in those scenarios, right? So this is more in the context where your migration involves some low-level changes in the application. But again, assuming that the method signatures are sort of the same, right? So you're not actually changing method signatures and so on. Because if you start doing that, then of course some of the tests would become obsolete on the modified application, and then you'll have to either modify the test cases or not use the ones that are obsolete.
I think this tooling can be viewed as a safety net for types of migration that are not involving deep refactoring. It's still a safety net to make as some kind of a sanity check to make sure that nothing crucial broke.
Yeah, those are some great points. Do you have REST API support?
Not yet, no.
It's on our to-do list.
Okay. And then the next question is, how do you define a unit in the unit test case? Will it instrument abstract, not to reach other layers, like the database layer, for example?
Well, so we basically start generating inputs at public methods, right? And if those executions reach certain point in the application where database access is made, then actually those will execute, right? And we have some capability for mocking some features for Java Enterprise Edition, for example, like JNDI lookups, we can mock those. But some of those actually would require some more tooling to add additional mocking capabilities.
Okay. And Rachel, actually, no. It looks like that's all the questions that we have for today. So thank you both so much for being here, presenting this. To everyone in the audience, I did put the link to the survey in the chat. So please fill that out. That helps us understand, where we hit the mark, where we missed it, and what we can do better. And I'll send out the recording, the slides, probably in 2 days from now. And I believe both of you are already in the Slack channel, right?
Yes, we are. So
yes,
we'd love to get feedback. So, reach us out on Slack, or, you can try out the tool, provide feedback on GitHub as well via issues. And so, yeah.
Okay, awesome. So there you guys have it. If you have any questions, please go to the chat, Slack, or put it on GitHub. All right, well, until next time, thank you all for joining. Bye.
Thank you.
Thank you.